Right, so the question that we're answering in this video is how do we graph the function -3 raised to the x plus 3 plus 9. And so the two things I usually consider when I go to draw the graph of a function is can we get an idea of what it looks like based on our knowledge of transformations. So what I mean by that is this is a variation on this function f of x is a variation on the parent function 3 to the x. And so based on our knowledge of exponential functions, we know that when the base of our basic exponential function, when the base is bigger than 1, we've got an increasing function. The x-axis is a horizontal asymptote, and maybe just one point of reference here at 0, 1. 3 to the x has to go through the point 0, 1. And so how do we get to the graph of the function that we're looking at? Well, the negative in front is going to flip our parent function upside down. The plus 3 added to the x is going to shift the function to the left by 3, and then the plus 9 at the end of the function is going to shift the graph up by 9. So we could get a pretty good idea of what this graph is going to look like based on our knowledge of transformations of parent functions. So I usually kind of just sketch in the reflection. Right, if we flip the graph upside down, it's going to look like this. Right, so this point would become 0, minus 1. And then let me go back to black. Taking this red graph, we're going to shift that red graph to the left 3 and up by 9. So just to get a quick sketch of what this is going to look like, let's see, this point is going to shift to the left 3, so that'd be -3, -1. And then up 9, that would be at -3, 8, so up here somewhere. And then, of course, the horizontal asymptote would also have to shift up by 9, so we'd have a horizontal asymptote up here at y equals 9, and the shape of the graph would be the same as this red one that we drew reflected. So what I usually like to do to make the graph as complete as possible is then we can go figure out where is the y-intercept and where is the x-intercept, and that'll give us a nice pretty graph and a little practice at solving exponential equations as well. So to get the y-intercept, we take our function and we put 0 in for x. So that's going to give us, let's see, this will be -3 to the third plus 9, so that's -27 plus 9, which gives us -18. Okay, so my rough sketch is quite a bit misleading, right? Obviously my y-intercept is off, right? So that's exactly why I go and algebraically find the y-intercept. If the y-intercept is at -18, then this sketch here is very rough. It's not precise at all. So what that means is also that my x-intercept is probably over here somewhere, right on the negative side. So again, that's why I go find these intercepts, so I can make my graph more accurate. So let's see what happens when I try to find the x-intercept of the graph. We do that by taking the function and setting it equal to 0. Now what we're going to try to do is get the same base on both sides, or you could use logarithms to solve this, but you don't need logarithms in this case. So I'm going to add this term to to the other side of the equation. And then we can simply write the left side as 3 squared. And since I then have the same base on both sides of the equation, that means that my exponents must be equivalent. So x is -1. Right, so again, my original sketch was not very well done because I didn't know exactly where the x and y intercept were. So it's going to look quite a bit different than this. This gave me the general shape, but it didn't give me a precise graph. So now that I know where I hit the y-axis and where I hit the x-axis, I can get a much nicer graph. So let's see if I can make this look a little bit better. I can make my tick marks go by 2's, so I can fit this all on here. Let's see, I'm going to need to come down to -18. See if I can fit this on. Did I get it right? 6, 8, 10, 12, 14. So here's -18. And I kind of had to squeeze that in. I didn't space my graph out very well. So that would be 10. Right, so my graph still isn't perfect because my artwork is poor, but this will be much more precise than that original graph. So let's see, my one point of reference was -3, 8. So that would be about right here. And of course on the original sketch I had an asymptote at 9. Whoops. Well, let's see if I can get this correct. -3, 8 would be more like right here. And then an asymptote at y equals 9. And I also have my x-intercept now at -1, since I found that. And then my y-intercept way down here at -18. So this will give me a much better picture of what's happening. My exponential function is going to come down through these points. And of course has to get close to but not touch the horizontal asymptote. Right, so that's a much better picture of what's going on with that particular function.